of these table covers. Usually you should these off. That we make to put on the table so that it doesn't get all damaged with people putting stuff on here. And what we need to do is make sure that this table is nice and flat. How many of you are starting on the mills? Okay, you'll get to do this. To make sure that the mill is nice, flat, clean, and everything, we have a couple of these really nice stones. This is called stoning the table, and we will stone the bottom of the vise that goes on these as well. You don't need to actually grind the table down 2 or 3 inches each time. Just take this lightly over, make sure you pretty much go over the whole thing. And what you're trying to do is find any raised metal that might have been a dent from dropping something on it. And then you'll wipe that off, clean it all off so that it's nice and clean, and then we will grab a vise. Like this one right here. Which comes with its own rag. In this case, this actually came off the CNC mill, got coolant all over it, so it's kind of sticky. But on it, we want to do basically the same thing. We want to make sure that you don't have any raised metal, and again, you don't have to spend all day doing this. Just make sure that you've got all the raised metal off of it. And normally there won't be any, just as somebody drops something on it, it'll dent it, and then you've got to sand that all off. Okay. I'm going to kind of do this in steps because I don't have any T-nuts and bolts I have to hold it down with. Okay, when you put this on, I want you to just kind of slide it back and forth like this. It's called ringing, like wringing something out. And it just makes it so if there was something under it, it would wipe it off as it goes across. Okay, what's this called again? That's exactly a vise. Okay, so we can set the vise on here like this, and then we'll need to know where to get our bolts to bolt it down with. This has got some real sticky, dried up coolant on it. It's just vegetable oil. It's kind of gotten dry. Don't lick it off. So I will show you now where you should find the bolts. So they're going to be in the tool room, and all the cutters that we're going to be using are going to be in here as well. They're going to be just right here. We did an indicator. Okay, this is an R8 collet or an R8 taper on this particular drill chuck. They're not just drill chucks, we use them for everything. This is a Morse taper. Hold these up in here. Okay. Find the chuck. This is the chuck. Can you see the difference? Mm-hmm. Jacob, can you see a difference?
I can't back here.
We'll bring him out. Tool room gets a little crowded with 23 people in there. So.
Thank you.
Yeah, okay, I got this on top of you.
Hey Alan, I need that wheel chuck with the R8 tape. Yeah. Yeah, the R8 taper is the one with the little tiny taper, and the Morse taper is the one that has a big long taper. So, talking about a lot of stuff that I expect you to learn. You good angle. So you'll need to know the difference between all these collets, all the tapers, all the names of all this stuff, and obviously we're going to talk about them again, but today's kind of our first day looking at some of these. This is a test indicator in this little blue box. What I've got it for is I need to make sure that the vise is straight with the table, because if I just throw it on here and start milling my frame, we want the sides to be parallel to the centerpiece that we're going to cut out, right? So the only way that you can do that is to make sure that this vise is straight with the way that the table moves. And the table moves basically this way and this way. So we're going to be cutting with our block in here like this, lengthwise, because we have power feed this direction and not so much this direction. And besides that, it kind of matches the vise, and you try and match what your work holding tool is as much as you can when you're cutting. R8 taper. Big one. Thanks. And it looks like it's going to lower. This lowers the. This is called. This part of the knee, or this part of the mill, is called the knee. This part of the knee is called the mill. Anyway.
Assuming because they don't pay for that's the one thing that people do is the talk whenever they're running around.
Well, actually, I think it's because it looks like that.
No.
That's my guess. I wasn't there when they named all this stuff. Okay, what I'm looking for. Okay, now this, remember the other day I told you that an adjustable wrench was like the worst thing to use to tighten stuff up?
Yeah.
Anybody remember me saying that?
Yeah.
We're going to use this up here because it's like the worst thing there is to tighten stuff up. But the problem that we have is that the brake right here is really close to the on and off switch.
Now, why did they design it that way?
Because it's right hand biased. What does that mean? They could have put one on the left hand, right? Would have been better. But they want to be, they figure most people are going to be using this hand to turn it on and this hand to drill with, or whatever, and so they've got all this stuff on the left hand side. Anyway, the problem is that you could reach up here and turn the spindle on really easily. So the rule is you always put the brake on before you put the wrench on the drawbar. Now the drawbar is just a big long bolt that goes all the way through. I should have pulled it out and showed it to you. But it's just a big long bolt that screws into the end of the R8 collet or R8 adapter or whatever. So put the brake on, and you just do that by pushing it side this way or this way side to side. Reach up here, put the wrench on, and tighten it up just nice and snug. It doesn't have to be super tight, and you don't have to use a 15-inch clip on it either. If that's the only wrench that's left, you can use it, just don't tighten it up as tight. Now, the spindle on right here, you can turn it on, and it turns the spindle on. This is the what? This is the what? Spindle on, yeah. Think you can remember those? Those are the two most important parts of the mill, so. Oh, and the vise. Okay, now the vise is still loose, right?
Yes.
That's going to be a problem.
Yeah, don't try cutting something if the vise is loose.
Yeah, don't put a vise on there without tightening it down.
Very good. Where did you get that from?
You know, kind of
Little bird folded.
Okay, it is basically the same idea as the lathe. If you start setting something up and it's time to go and you've got to clean up and your mom's waiting for you with lunch or whatever, make sure that you finish. Or you come and tell me, hey, my mom's waiting to take me to lunch.
Finish this
I'm
one.
really hungry. And what I'll do is I'll actually have you take it all the way off again, and you put it back on next time. Okay, now most people, they'll take the drill chuck and they'll tighten it up with the chuck key for everything. We don't need to have this tightened up with the chuck key because we're not going to be turning that. All we want it to do is hold this indicator so that we can come up here, touch this vice jaw, set the indicator at 0, and I should have done something. So I'm going to try and get this a little bit more straight than it was. Because Justin was giving me a bad time.
Yeah, it still looks perfect.
So don't
over
take
here.
that off once it's on, guys.
Alright, let's see how close it is here. Okay, so you can move it along here any way that you can. It's got a big dent in it right there. I didn't get it on straight at all. So it's going this direction, which means that it's touching less. So it's actually sitting in the vise like or on the table like this. So if I move this back, you can see that as I move the table this way, it goes plus. As I go that way, it's minus. So if we're moving this direction, can you see that from there, Dusty? Anyway, those of you who can't see it, probably are working on a different machine, right? So basically what I need to do is just kind of, before you tighten this, you can kind of tap it around with your hand. After you tighten it up a little tiny bit, you'll need to use a brass hammer. So I'm still at like plus 10 right there.
How close do you want to be?
5,000
Get your name back.
or less.
Brass hammer.
Thanks.
You want it?
I do. Appreciate you doing that. So Dusty asked how close do we want it, and basically we're doing aerospace stuff now. So we want within 1,000. And 1,000 is halfway from one line to the next. So it's at -2, going from -2 to this. Now this particular vise, somebody helped us put a little dent in it so that it holds better, I guess. So just kind of ignore the dent, just go from one end of the jaw to the other. I'm going to snug this side down just a little bit so it doesn't move very far. I'm going to tap this over. Now this whole thing is pivoting on this bolt, so I'm going to be off still quite a ways, but it should be a lot closer than it was before. Okay, see, so this side went a little bit more minus as I moved that other side minus. I'm going to turn this to 0 now, and go back here and do it one more time. I'm pushing the rapid traverse button, which is this little button right over here on top of the key, and I'm about 3 thousandths off. I'm just going to move it to just barely past 0, because this side again is going to swing away too. Let's snug this down.
Question.
Good job.
Why are you using a brass hammer instead of a
Good question. Why am I using a brass hammer instead of a steel hammer?
softer? It's not going to hurt anything.
Softer, it's not going to hurt. This will get bended like this instead of this getting bended.
Still
Brass
hammer's
hammer's
the
a
other
lot
way.
cheaper.
What?
Still hammer's the other way.
Steel hammer's a hardened piece of steel against a soft piece of steel. And this vise, this particular vise right here, you can replace this one for about $500. So if you want to, I'll let you find me
Plus shipping and handling.
I think that's almost with shipping. Might cost a little more to handle it though. The UPS tip is awful expensive these days. Alright, so I'm within a couple tenths there, about 1,000. Just tighten up both sides until it's nice and snug. We'll check it one more time after we've tightened it up. Set that right back in. It might be off a little bit, and I thought I was a little closer, but I've almost spent too much time talking today, so we're within half of in between two lines, right? Where's that going? You got it, Jeremy? Good. Jeremy says we're good, so we're good.
Good enough for my machine.
Okay, good enough for a cannon. Going to the moon. Actually, Mars is where we're headed to next.
We're
Isn't it?
building a cannon, so it's just gotta be close.
We're shooting the moon.
Okay, so I'm going to take this out.
Non-operational.
Take these apart. Don't unscrew this all the way. If you unscrew this all the way, the little brass piece will fall out on the floor. And then you have to tell everybody in the class to stop and help you find it.
Okay.
Because that's the rule. Whenever you lose something little, you can't find it, we all stop and find it before we sweep it up and throw it in the trash. Okay, so that's part of the setup on the mills. That is something that I will expect you to know how to do. Whenever you come over, the very first thing every day, I want you to double check the vise and make sure it's dialed in straight. Most of what we're going to be doing is not going to be rough and vicious enough to move them, but vibration and force moves anything, even these when they're bolted down tight. So check them every day when you start, and then you'll know the device is dialed in. That way you can't blame me if your cuts, if you're cutting from corner to corner on your cannon frame, right? Don't cut from corner to corner on your cannon frame. Okay, any questions on how to set up the device on the mill? That's kind of what we talked about. We talked about the brake, the on-off switch. This is how you select the RPM. So in 1 minute, this is not a geared head. Well, for the most part. There actually is a gear in here that changes it from high range to low range. You notice that there's numbers on around the outside of this ring that are lower than the numbers that are on the inside of the ring. If you're in low range, you would be using the smaller numbers. If you're in the high range, you'd be using the bigger numbers. And this little knob over here allows you to shift gears, and you'll need to turn the spindle while you're doing it. Now we're in low range, back into high range. And this one has to be off to change from high to low, but then it has to be on to change spindle speeds. Right now we would be at about 700 RPM, but we can go up to 3,000, and we want to stay out of the red zone. So about 3,000 is the maximum on these spindles on the mills too, just so we don't. Yeah, that real big whine at the end you heard was from somebody turning this without the spindle being on. Normally they don't do that, but there's a plate inside there that starts rubbing against the pulley a little bit. So make sure that the spindle is on or off. On. What about on the lathe, on or off? How do you know which is which?
That's a no, that's a way.
One's vertical, one's horizontal.
Okay, the mill has variable speed, so the spindle has to be on. Lathes have a geared head, so the spindle has to be off. See you on Tuesday.